All right, looks like we are live. So I'll just give it a couple minutes so that everyone can go ahead and join the live, and then we'll go ahead and get started. All right then, how is everyone doing today? How are we doing? What's going on? What's new? Doing great. Trying to forget that school starts soon. Yeah, school does start soon. For me, school starts in 4 days. Actually, it starts August 10th, which is a Wednesday. So that's kind of like a weird time to start school. But hey, I'm going into my senior year. It's my last year, so I'm just glad to get it done. All right, looks like everyone's in. So let's go ahead and get started with lesson 11. And before I start, coding or anything, um, I've decided to take us out of our project phase, and we're going back into our learning phase. Because I was, thinking, and it was like, how long are we going to spend doing the same things over and over and over, but with just different projects? So I figured this would be a good excuse to just go ahead and just resume where we left off with learning Python. So that's my first announcement. My second announcement is that tomorrow there won't be a review lesson. I'm going to be out of town. That's just for tomorrow. Um, every other Sunday should be normal, same plan that we always have. But tomorrow there won't be one. So those are just it. Hey Maria, how you doing? So yeah, let's go ahead and get started with lesson 11. So when we spoke earlier, I told you guys that we had basically learned the basics of Python, right? We've done all of our basic beginner stuff and whatnot, and then we spent about 2 lessons working on projects to enhance what we know, to solidify what we know. Now we're going to be moving on to the next phase of learning Python, and that is what is called OOP, otherwise known as Object Oriented Programming. The object-oriented programming is what we're going to be looking at next. And I'm not going to lie, this section is going to be very abstract. You're going to have to see things in your mind, but we're going to take it slow. We're going to go through these things. We're going to talk about them first, right, conceptually, so we understand them, and then we're going to bring them into our code. So the biggest thing with object-oriented programming is that it makes use of objects, hence the words right here. So what is an object? Well, as I said earlier, let's talk about it in terms of a real world sense, and then let's bring it into our code. So an object, a prime example would be a car, right? So let's say there's a car sitting in front of you. How would you describe it? Well, you could use the color, right? You could use the manufacturer. You could use, the size of the wheels, right? These are all ways I'm able to describe this car, right? So keep that in the back of your head. Now, how can I, describe what this car can do? This car can reverse, it can go forward, it can accelerate, it can park. So what I've basically broken that into is 2 different things. A car has attributes, such as its color, color, manufacturer, I think I spelled that right, wheel size, attributes, there you go. The car has attributes, but a car also has inherent functionality, right? You're able to drive, you're able to park, you're able to reverse, right? Because with driving, that's a series of steps that you're doing. So you could sort of think of it as a huge function, right? When you drive a car, you're holding the steering wheel, you're working with the gear shift and whatnot, you're checking your mirrors. That there's a bunch of things that go into just driving. So that's sort of the car example. The next example that I like to use to discuss an object would be humans, right? So let's treat it how we treated our cars. If there's a person in front of me, how could I describe them? I could describe them with their name. I could describe them with their hair color. I could describe them by, I don't know, their height, right? These are all things that I can use to describe them. Let me bring this down here. So again, I said hair color, I said height, I said name. These are all attributes. Now let's think of some functionality that humans have. Well, we can speak, we can eat, we can sleep, right? Because when you speak, your vocal cords are firing, your brain's firing, your synapses and whatnot. It's a whole process to just be able to say a word that's extremely complex. So you could sort of say it's a whole function in and of itself. So how do we feel about how I've described this so far? I know this is a weird stopping point, but again, this is one of those things that I want to take it kind of slow. We'll go through it very carefully just to make sure that later on we don't have any issues with our basics. But how do you guys feel about what I've discussed so far? Do you guys want me to go back over it? Maybe get a different example? And again, I hope my chat isn't broken like last time. Let me actually pull up a different stream just to make sure. Okay. Okay, see another example? Okay. So let me think. You have a car, you have a human. What are some other things? I'm trying to think of good examples that are like pretty like simple. I'm looking around my room right now. Okay. How about a phone? Okay. Attributes. Practice it. Oh, I'm sorry. Okay, so it looks like we're all good with this. Okay, that's awesome. So actually, I'll leave this here just so we can reference that. So as I was saying, these attributes, right? Color, hair color, height, name. These are all ways for us to identify a person, right? Identify a car, describe them. And these are like descriptors, right? And from here on out, I'll refer to them as attributes. So that's what an attribute is. And basically, a gosh, where was I? Yeah, okay. So the reason why we use object-oriented programming, right, is basically to create our own data types. Create our own data types. So what does it mean to create our own data type? Well, we already know some of the primitive data types, right? The data types that come with Python. They're called primitive data types. Let me clear this so I can comment that out. So we have our primitive data types, right? So we have our Booleans, we have our integers, we have our floating point values, we have our strings, and we have all of those. So those are our primitive data types, right? Booleans are used to represent true or false. Integers, your whole numbers. Floating point, your numbers with decimals and whatnot. Strings, entire sentences. But what if there was a need for you to sort of represent something a little bit more sophisticated, right? And that basically that enhanced sophistication is why we use objects. And it allows us to keep everything much more easier to understand. And again, you'll see that when I start writing the code. I'll show two different ways to approach it. So now let's actually go ahead and start writing some code because I think conceptually we are where I want us to be. So I'll clear this out. So when you're creating objects in Python, you're basically creating something called a class. And again, this will come with practice and stuff. So again, these keywords may seem a little bit confusing, but again, practice, practice, practice will, enhance what we know. So let's say I wanted to create a human object or a human class. Okay. Let's come down here to our line 7. So to say this, I would say class, right? Declaring a class, space, and I'm going to put human in capitals. This is the name of my class. I'm creating a human. Put a colon here. I'm indenting into the next line, and I've basically created my class here. And now to basically add functionality to it, we'll say def, sort of like we're defining a function, underscore, underscore. Right? This might look a little bit confusing, so just stick with me here. Init underscore, underscore. In our parentheses, we're going to put self, and then we're just going to come down here, and we're going to put pass. We've created a class. So this might seem a little confusing, so let's go through this line by line. Now, the first thing I want to actually look at is this pass keyword. This has nothing to do with classes in general. This is just to like fill space. Basically, the pass keyword is like if you ever get to this, like, look, if I leave this blank, right, I get an error. This pass keyword is basically like when you don't know what to type, so you just put this there, so you don't get an error thrown. So this is not related to classes. This is just so I can show this basic general structure. So these are the two important lines, and I'm just putting this keyword here to make sure that an error doesn't get thrown. So this pass, don't worry about it. I don't think I'll use it past this example. Anyway, so let's take a look at these two lines. So pass doesn't do anything. Yeah, it's just there to fill up the space so that if an error doesn't get thrown. So it's sort of like if I had like name is equal to Varun. Yeah, so the function isn't empty. Yeah. So if I said if name is equal to Varun, print something, right? If I run this, it prints something. But if I leave this blank, on the other hand, an EOF error, syntax error. If I put pass though, nothing happens. It just skips it. So that's what we're doing. We're just doing that so it doesn't, throw an error. So again, back to looking through this line by line. So it's like break. Not really. Remember, break is what's used in loops to break out of those loops. Pass, on the other hand, is just there. Think of it as just something to fill the space so that Python's not like, oh, there's nothing here, it's an error. But in terms of functionality, it doesn't really do anything. It's just to fill, All right. So let me go through these line by line now. So, yeah, so the code works. Yeah, basically. So line 7, what am I doing here? Well, I'm going to declare a class called human. All right. So we're declaring a class called human. And usually when you create classes, their names are always capitalized. Like that's the first thing. So if I was creating a class about cars, like that, or something like that. So again, class names are usually capitalized, and that's again general convention. Now, what is this? What is this def init self doing? So this is where it gets a little bit abstract. So this def keyword, right? It's telling us, hey, this is a function, right? So keep that in mind. We're looking at a function, but you'll notice that within the arguments, the parameters set for this function underscore underscore init underscore underscore, I give it self. Okay, so I have this def, which is telling me it's a function, but then I have this self. So this is actually called a method declaration, or sorry, just a method. So again, if you remember from a couple lessons ago, we talked about methods. And again, we went over them really briefly because I was saving them for this lesson. So again, if you had something like my list, Varun, oops. and I wanted to add something to this list, I would say my list dot append. I put Luke or whatever I want to put in there. This dot append is basically a method because it's tied to this list class. Does that make sense? How that works? So again, these methods are tied to the class itself, to the object itself. So this underscore underscore init underscore underscore, and I'll just refer to this as init because why am I going to say the underscore is 4 different times? But this init method is tied to this human class, if that makes sense. So just stick with me. So again, going back to our car example, right? A car can park. Can a human park? Can you turn on your blinkers as a human and indicate you're going to turn into this parking lot and then just turn your wheel in? No. That means that parking is sort of exclusive to cars and vehicles in general. So it's a method because it's tied to them. So again, this is actually called not just a method, but it's called a dunder method. And again, we'll talk about this dunder later. I'm just bringing up the word. So what this underscore underscore init is saying is when this is created. Okay. So think about it like this. And again, I apologize. It's going to get really confusing because I'm going to switch between real world examples and then the code, real world and then the code. And I promise it'll make sense. Don't worry. But think about it like this. When a child is, say, born, right? Out of out of the box, that child has, inherent things that you can refer to them with, right? Their skin color, their hair color, their name, if they get a name that early on. So as soon as they're created, as soon as they're initialized, they have certain attributes, the ability to do certain things, right? As a child, babies come out, they cry. They're able to do that as soon as they come out. So it's sort of like as long as they're created, that's the first thing they're able to do. So that's what this init function is like, they're able to do. This init stands for initialized. Initialized. And initialize just means like created or started up. So what I'm going to do here is I'm going to treat it just like I talked about with the baby example. And I'll just say, okay, so the baby comes out. We'll say, I'm just pretending to be a baby here. My hair is black. Print my name. My name is Varun. Okay. So again, now I'm going to come down here. And what we're going to do here is we're going to create an instance of the human class. So what does it mean to create an instance? Well, an instance, again, treat this human as a blueprint. You can have multiple humans, right? I can use this general structure of a human, of this class, to basically create other humans. Each of those humans would then be an instance of the class. And again, we'll see it right here. So let's say I want to say Varun. That's just my variable name. I'll say Varun Patel is equal to a human. Okay, so we have our class name. If I run this, we don't get any errors. But just like with a function, you have to use those opening and closing parentheses to actually tell this class to do something. So we'll say Varun Patel is equal to a human. Okay, that's what we've got. So if I run this, so I've created an instance of my class called Varun Patel. Okay, now Varun is an instance of this human class. Okay, now this human class has been started up, right? That's what that opening and closing parentheses does. It's been started up, and I've specified that whenever my class is started up, right, when it's initialized, I want to go ahead and print my hair is black, my name is Varun. Okay, so you'll note that I didn't actually have to say like Varun Patel dot underscore underscore init underscore underscore, right? If I do this, it'll run this 2 times because now I'm calling this actually. But when I'm running just human by itself, it automatically runs this init. So how are we feeling with this? I just want to get a general gauge. Are there any lines that we're feeling kind of iffy with? Okay, we're doing good. Oh, that's awesome. That's awesome. Okay, so I'm going to, is everyone okay? Any questions? Good, but can you go into self? Okay, yeah, I can go into self. So again, this will be sort of ahead of what I wanted to discuss, but I feel like it's worth talking about anyway since we're here. So think of yourself as you're your own self, right? SELF, right? We're still in this human example. How would you describe yourself, right? You have black hair, you have um, whatever color skin and whatnot. So basically, what this self allows us to do, and we'll see it later on, is that throughout our class, we will be able to essentially reference our own um, attributes, and that's as much as I want to go into it right now. We'll see it in the code, but just think about self allows us to reference, say later on in our class, human class. I wanted to create a function, or sorry, a method where I dye my hair, right? So that self, I can use that to change my color, if that makes sense. And we'll see it. We'll see it a little bit later on. Maybe we can do another example as well. Yeah. Um, let's go through with this example, and then I'll switch to the car example as well. We'll have them both in tandem, but I just want to finish up with going over the general structure of our classes. So that is our init function, right? When something is initialized, right, then this will run a series of whatever, right? It'll print my hair is black, my name is Varun. Okay. Now, humans are a little bit more complex than just that, right? Humans have hair color, skin color, right? Those attributes that we talked about earlier. So how can we pass those into our human class, right? Well, again, let's think of some attributes that we want our human to have. Well, we'll say name and we'll say hair color, okay? So whenever I initialize, right, whenever I call this parentheses, this opening and closing parentheses, there's also a way for me to pass in certain values. I'm going to come here, I'm going to put self name hair color, okay? And just stick with me here. I'm going to come down here, I'm going to say self.name is equal to name self.hair color equal to hair color. Okay. And again, just stick with me. Okay. So what have I done here? Well, again, we have our initialize function, right? But now it's going to take a name and a hair color. You never have to give it this self. There's nothing that you have to give right here when you're initializing. But now if I run this, you'll see type error. My init function, right? So again, that's just this right here, is missing two required positional arguments, name and hair color. So because I haven't given them a name and a hair color right here, it's not able to do anything. Okay. So now, again, we'll see that. Now let's talk about what this is doing. Okay. Self.name is equal to name. Self.hair color is equal to hair color. So again, as I said earlier, self, right, this keyword self, is sort of used to represent all of our features, our attributes, our abilities, right? So when I say self.name is equal to name, right, this name corresponds to the argument that will be passed into my init function, okay? I'm saving it to self.name. So now I'm making it so that self.name is something that's accessible throughout my entire class. So any method will be able to access it and then things like that. And then I'm setting my hair color to it as well. So we're going to create an instance of our human class, but now we need to give it a name and a hair color. And again, the name is the first one, so I'll put Varun. If I run this, you'll see still get an error because I'm missing the hair color one. So I'm missing one more positional or required positional argument. And then I'm going to give my hair color, I'm going to say black, okay? If I run this, No errors, right? We're not printing anything, but there's no errors. I'm going to go ahead and create another instance of my human class. We'll call him John Doe. John Doe. He's a human. John Doe's name is, well, first name is John. And his hair color is, we'll say he's blonde. Okay? We're using this human class, right? This is the same sort of blueprint, but we're using them to model two different things. These are both two different instances of the same class. And they're different because one is Varun with black hair, the other one's John with blonde hair. Okay? So again, it's kind of weird right now. Now what I'm going to do is we're going to basically create a method where the person just prints out, my name is blank and my hair color is blank. Okay? So again, it's just kind of like a function kind of. So I'm just going to def, I'm going to call this introduce. Introduce. And I'm going to pass in this self. Every time you create a method, you're going to pass in this self. This would be the first argument you have. Why are we adding self? Well, you're adding self so that, again, it allows all your methods and everything else to access those attributes that we set. Okay? So I'm going to say def introduce. I'm going to say print my name is blank and my hair color is blank. Okay? Put this into an F string. And then right here, I'm going to say self.name. Right? So we're pulling this self, right? That's what we're passing in, and it's able to pull our name from there. That's why every function in a class, or sorry, every method in a class has to have that self passed in. So my name is self.name, and my hair color is self.hair color. Okay? So now I'm going to come down here. And again, if you remember we had like my list and we did like my list dot append. We're going to do the same sort of thing here. So Varun Patel is the name of the person. I'm going to say Varun Patel dot introduce. That's it. Again, you see, why am I not passing in a self here? Because Python automatically does that for me, so I don't have to do anything like that. So we'll say Varun Patel dot introduce, and we'll say John Doe dot introduce. Okay. If I run this, the first thing runs, my name is Varun and my hair color is black. The second time I do this is, my name is John and my hair color is blonde. So let's go through this line by line and see what we're working with. Okay, start here at line 7. Again, we're creating a class, right? And this class is used to model a human, okay? Now, my first method is called a dunder method, and that's that init. Now, this init is basically saying, when I'm creating this human, right, because this is where you create the human, I want you to give me its name and hair color. And basically, what I'm going to do with that name and hair color is I'm going to save them in a way where all the other methods in my class definition will be able to access them, right? So that's why I'm saving it to the self.name. Because in self is sort of used to, again, this is why it's so abstract. It's used to represent this whole class as a being. Okay, so that's when this is created. There's no need for me to actually call this because it happens automatically when the class, or sorry, when an instance of the class is created, right? This is where the instances of the classes are created. Now, this human class, or class called human, also has a method called introduce. And what that introduce class, or sorry, method does is it's going to print out the attribute name and the attribute hair color. So when I come down here, lines 16 and 19, I'm creating two instances of my human class. One is going to be called Varun Patel. The other one's going to be called John Doe. Now, both of these are of the same class, but they're different because one has been given Varun as its name and black as its hair color. The other one has been given John as its name and blonde as its hair color. So their attributes are different. So again, if these are people standing in front of me, right, there's John right here and Varun right here, I would say Varun is the one with the black hair. John is the one with the blonde hair. So that's why I'm creating these instances of this human class. Now, with these instances, I'm then able to call a method, right? This introduce method. And when I call that, right, I say Varun Patel that introduce because this introduce is again tied to this class. It's going to say my name is self.name, right? And we set that right here. And my hair color is self.haircolor. And we set that right here. So running that, Varun Patel would say, my name is Varun and my hair color is black. My name is John and my hair color is blonde. So how do we feel about that? Makes sense, actually. Okay. I mean, we'll do another example with a car as well. So, and that car, will be a little bit more complicated. So, is everyone else okay? We'll give them a second if they need a copy of the code or anything like that. I think so. Okay. Awesome. These are rock stars. So that is our human class. What I'm actually going to do is I'm going to save this to a file just for future reference. If you guys need to go back and look at this, it's always good to have. We'll just call this human class.py because now I'm going to use a car as my example. So I'll cut this out, paste it in here. Okay. So if you need to reference it, make sure to save it. So now we're going to, well, earlier we used a human, very basic. And that's just so that we can understand what we're doing. Now I'm going to use a car, and we're going to sort of expand this a little bit more. So we're going to create a car class. Okay. So how do we create a class? Well, we use our class keyword, CLASS. This is used to describe a car, right? We're going to model different types of cars. So we're going to give it CAR, right? Usually it's capitalized. We do our colon, we come down here. Well, it's always good to have our dunder method, right? So that when we initialize our class, we can give it our attributes, right? We can give it our name of the car, not the name of the car, the manufacturer of the car, the color of the car, the year it was created, the def underscore init. Oops, init. Again, we pass in that self all the time, so because it allows our functions and our methods to directly manipulate the attributes of the class. So again, we're giving it our self. That's just how it goes. Now, what are some things we want our car to have? Well, we want our car to have a color. Manufacturer. Oh, sorry. We'll have the year it was created. What should we have? We'll have the type, like a sedan, or if it's like a racing car or whatever. That sounds good enough. Okay. We'll put our colon down here, and I'm going to say self.color equal to color, right? Because we're taking all these values that we give it, and we're just going to save it so that our self, again, because it allows us to reference that later on in our code. Self.manufacturer is equal to manufacturer. Self year is equal to year. Self.type is equal to type. Okay? That's our init function. Pretty straightforward, nothing too different from what we did with our humans. So that's our basic, general structure of a class. So let's actually go ahead and create some instances of this class. Say car, create this car1, car2, car3. Okay, we'll create 3 instances. Each one is going to be of a car, right? Each one's going to be a car. And you have to remember that because, as soon as this opening and closing parentheses is called, this init function is, or sorry, method is going to be directly called. So we have to give it those positional arguments, otherwise we get a of error. Okay. So our first car, let's figure out our color, manufacturer, year, and type. We'll say that it is black. Oh, geez, excuse me. So it's black. It is manufacturer. We'll just say it's Honda. Say it's a 2007. Make that as an integer. And type, we'll just say sedan. Okay. Now this next car, we'll make it blue. Say Mercedes made it. We'll make it nice and fancy. Mercedes. We'll make it 2020, so it's a little bit more, newer. Make it an F1 car, just so it's cool. Our last car, we'll make it red. We'll make it a Lexus. Actually, that makes no sense. We'll make it a Toyota. Toyota. So this is a 2010, and we'll make it a truck. It doesn't really fit. How can a car be a truck? It's an SUV then. All right. Pretty straightforward. So we've created 3 different instances of our class, right? So this is car 1. Car 1 is black. It's a Honda, made in 2007, and it's a sedan. Car 2 is blue. It's a Mercedes made in 2020 that is an F1 car. Car 3 is red. It's a Toyota made in 2010, and it's an SUV. Right? These are all, different instances of the same class. Okay? So we've created our cars. So we just have this car sitting in front of us. So, what do you do when you drive a car? Well, let's explore that. Let's say def drive. Okay? We're just going to take our self. We're going to say, well, you drive the car. We're just going to make this a bunch of print statements. It's pretty straightforward. We'll say print. Opening the door, right? You open the door. That's a bad example. We'll say, just say turning on the engine. Turning on the engine. You turn the engine. You get a nice little vroom noise. Vroom. You just say drive away. Okay? It's just a bunch of print statements. So the car is driving. Okay? Now let's say we're going to basically call something to say, we're going to create another function called upgrade. Change color, right? Let's just say we took it to the body shop and they're going to change our car's color into a color that we want, right? So again, you pass in that self, and then we're also going to pass it the color that we want to make it. We're just going to say self dot color, right, is now equal to this new color that we've passed in here. Okay. Let's work with this. So we got car 1, car 2, car 3. And again, if we do car 1.drive, we copy this. Doink. Car 2.drive, we do car 3.drive. They all do the same thing. Turning on engine, vroom, drive away. Turning on engine, vroom, drive away. Turning on engine, vroom, drive away. Okay. Pretty straightforward, calling a method with no arguments. Now, what if we want to go ahead and change their color? Change color. Change color. Change color. If I call this an error, we're missing that one required positional argument, color. So let's give them some colors. We'll give them some extravagant colors. We'll say green. We'll make car 1 green. So it's going to go from black to green. Car 2 is blue right now. So we'll make it go from blue to orange. Car 3 is red, so we'll make it go from red to purple. Pretty flamboyant colors to be rocking. Okay? We run this. Nothing happens. We're not printing anything. Right? So we need to somehow check that these attributes have been changed. So what I can come down here and do is say print car 1 Oops, let me copy this actually. Car1, car1. So I'll make this car2. I'll make this car3. Again, we're changing that color attribute. So if I say print color car1 dot color, we should hope to see the new color that we assigned it. Again, outside of this code, right, outside of this class, we're still able to pull those specific attributes. Car1 dot color, just like how we're able to say car1 dot change color. Okay. So I run this. Car1 started off as a black sedan, right? I then changed its color to green, and now when I print out its color, it gives me green. Car2 started off as a blue F1 car. I then changed its color to orange, and now when I print out that color, I get orange. Car3 was a red SUV. Okay. I then changed its color to purple, and when I print that out, I get purple. So how do we feel about, so what have we done here? We've created our car class, right? And I think we've basically done what I wanted us to do. We've created two methods, and one of our methods takes an argument, right? This color method, okay? And we've also worked with passing in multiple attributes for our initialize method. So how are we feeling with that? Can you print all of the info together in itself and color? What do you mean? What do you mean by that? Do you want me to be able to print like all of these attributes? Okay, yeah, we can do that. Yeah, you can do all of those. Here, let me just okay, so we did color. So now let's do manufacturer. Manufacturer. And just like that, I'm able to access their manufacturer, their year, right? Pretty straightforward. Or no, I meant all together. So do you want me to print all of these attributes? Do you want me to create like a method to do that? So I'll just say car features. Car features. All right, we're gonna say self. We're just gonna print our self.color. We're gonna print our self.manufacturer. We're gonna print self.year. And we're going to print self.type. Okay? So let me clear this out. Oops. We're running this method called car features that doesn't take anything, and it's just going to print out our car's features. Our features. Oh, you don't have to create another method. Again, you can just put it like in this, in our init. Run that, it'll do it. So I'm just saying, I just wanted to keep it organized. But yeah, basically all of these attributes, you can access them whenever you want to. There's no like restriction on not being able to do a specific type of thing. But let's say you're trying to pull up an attribute that doesn't exist. So let's say I want to say car1.driver, for example. I print that out. Well, my car1 doesn't have a driver. That's not something I set. It doesn't work, right? So if I wanted to really drive, add something, I'd say car1.driver is equal to like Lewis Hamilton or something. And then if I, print that out, it adds that attribute in there. So classes are pretty versatile in Python. Really easy to work with. You can set those things. You can change them outside of the code. You don't have to create functions to do them either. You can directly manipulate them. I just added in that method just to sort of give an example for what we're working with. So how do we feel with this? Our first big sort of step into dabbling with classes and objects. Cautiously optimistic. I'll take that. I think that's a good way of describing it. Cautiously optimistic. To be honest, when I was learning to code, I actually like dodged learning object-oriented programming. Like I just straight up avoided learning it because it was just this whole thing that just seems so abstract and complex. And it didn't take me till like a year after I like properly, started coding before I sat down and actually decided to learn it. And it totally changed how I code. Like everything I do now with programming is object oriented. Everything is its own class and whatnot. But I think everyone's looking good at it. So let's go ahead and continue on. And we're gonna save this to a file as well, just for future reference. Class.py, in case you ever get confused working and you want to save this, you can always reference it. Oh, not human class, car class. So there we go. So we basically did everything I wanted us to do in terms of, learning. So now let's do something a little bit more fun and switch to a little mini project. And I think this mini project will take up the rest of our time. Basically, what I want to do is create a OOP, object-oriented programming, object-oriented programming. It's an OOP representation of a deck of cards. What do I mean by this? Well, if you look at a card, all cards are at their most fundamental level, sort of like the most basic thing, right? Every card has a value, every card has a suit, right? Those are two things that every card has. So, what if we created like a card class, right? And we use that to create instances of that, if that makes sense. Let's go ahead and do that. So, we're going to create a class called card, right? Def init. Now, when you look at a card, what does a card have? It has, well, we have to pass in self, first of all. It has a suit and it has a, what was it again? Is it, yeah, value. So we're going to say self.suit is equal to suit, self.value is equal to value. 1 second. Just want to pull up. I think I had a diagram that I wanted to show. That might make this look a little bit better. I just need to find it. Oops. That's a spoiler. And that's actually supposed to be over here. Okay, there we go. Sorry about that, folks. Okay. So every card has a suit. Every card has a rank. That's what I meant to say. Rank. Like you have your, your ace, your king, your queen, your jack, your 10, 9, ace, and all that stuff. And every card also has its associated like point value, right? And again, it depends based on the game you're playing, but we'll just create our own set of point values. Self.point is equal to point. All right. Now, let's say I wanted to create a function, or sorry, a method where I take all these attributes of my, my card class, and I'm able to print them out in a way that's super nice and clean looking, right? And this is what I want it to look like. I'm going to print it out here. So I want this to look nice like this. So you have your suit, right? And then you have your rank, and these cards all have their own associated point value. So I want it to look nice and pretty like this. So let's create a function, or sorry, a method that's able to sort of replicate this. Sort of like an ASCII card. So say def print card, okay, self. So the first thing I print are these little top sections right here. That's my top and my bottom. I copy this, paste that there. Within that, I then have my my body section. Hit print. Underneath that, that's where my rank will go if it's like king or queen or whatever. And then underneath that, I'll have the suit one more time. Okay. So that's our general structure of our card. We wanted to print it out so it looks really, really nice. Okay. Now you'll notice that we can't just use this for every card. Every card is different. So what we can do is we're actually going to go ahead and make these F strings. Okay. And right here, where this diamond is, we're going to replace that with self.suit. And where this diamond is, we're going to replace that with self.suit. Because for every card, it's going to be different. And then right here where this K is, for K, we're going to replace that with self.rank. It looks kind of ugly right now, but stick with me. We'll see how it turns out. So now I'm going to come down here. We're going to create an instance of our class. We're going to call this card1. Okay. Card1 is a card. And let me actually pull up the symbols, the suit and rank and whatnot. And put it in, I'm going to put it in chat as well. Let me just format it right here. I was using this in some old code. That's why it looks like it's in a list. Let's get rid of that so you guys can reference it. Yeah. So I'll put that in chat for you guys to use. You can copy it into your code. So what do we want our card suit to be? Oh, we'll make it a heart. I'll just take this heart right here, put it in there. What is its rank? We'll make it a king. So it'll be king of hearts. And we'll just say for our purpose, the king is worth 10 points. Okay. Run this, no error, right? We're not printing anything or anything like that. So now let's go ahead and say card1 dot print card. Okay? And now again, I don't have to give it any attributes because it's directly pulling from self. If I run this, look at that. We have our card. So we have our heart right here. We have our king. And if I print card1 dot point, right, this point attribute should get 10. So look at that. It's a nice way of representing a card. So how do we feel about what I've done here so far? We've created a class called card, right? And every card has its own suit, its own rank, its own point value. Then I've created a method that takes those values and sort of prints them out in a nice formatted way so it looks like its own card. So how are we feeling with that so far? Okay, I'm not seeing any questions, so let's just keep moving on with it then. Or maybe my chat's broken, who knows? Oh, good, I believe. Okay, awesome. So we've used this to basically create just one card. What if I wanted to create a whole deck of cards, like 52 cards or whatever, however many cards there are? How can I accomplish that? Well, I can use a for loop. Now, how am I going to use a for loop with this? Well, first, let's sort of create our structure. Let me get rid of this real quickly. So again, we're going to have a deck, right? And we're going to make this a list, right? Because that's basically what a deck of cards is. It's just a huge list of cards. Okay? Now, I'm going to have a list of all of my suits. We have our heart, right? We have our clubs, our spades, our diamonds, everything. So we have all of our suits. Now let's get those ranks again, because those are the ranks that they have. And I actually already have this in some old codes. I'm just going to go ahead and copy this into mine. Save us some time. And I'll put it in chat as well so you can pull that. Okay. So every car has its suit, its rank, and then we have our points. I'll put that in chat as well. Oops. Okay. So we have 4 lists that we've created here, right? We have our deck, and that's basically where we're going to be able to save all of our cards to. Okay. And then we have suits, ranks, points. So these are all the possible combinations and permutations of, of cards that you can have, right? So we go suit. So you can have an ace, king, queen, jack, 10, 9, 8, whatever, whatever, whatever. And then you move on to the next suit. You can have all of these. Next suit, all of these. Next suit, all of these. So on and so forth. And what we're actually going to do is we're going to take this rank and this point system, and we're actually going to turn it into a dictionary. I'm going to call it, we're just going to call it point dictionary. I'll just say rank and point. All right, we're going to create this dictionary. So our keys are going to be all of our rank values. So an ace will be 11 points. A king will be 10 points. A queen will be 10 points. A jack will also be 10 points. A 10 will be 10 points. I'm wondering, why isn't there not just like a 1-0 here? Well, because if we put a 1-0 in here, this would mess up the formatting of the cards. I'm just going to put T for 10. We have our 9. That's a 9. We have an 8. That is an 8. This is pretty tedious. A 7 is a 7. We have a 6. That is a 6. We have a 5. That is worth 5 points. And I'll just put this in chat as well, so you guys don't have to like slowly go through this. It's so boring. 3 going to be a 3. A 2 is going to be 2 points. A 1, actually, we'll just say ace is 1 as well, so don't worry about that. Okay, let me go ahead and copy this and put it in chat. So with that, we can actually get rid of this whole rank point thing. Perfect, perfect, perfect. Now, what we're going to be doing is using our loops to basically go over each of our suits. And every time we go over each of our suits, we're then going to use that to go over each of our ranks and their associated points. And then we're going to feed that information into our class, our card class, and then we're going to save it to our deck. Zoom out just a little bit. Hopefully it's not hard to see. So what we're going to do is we're going to say for suit, I'll call this suits. Suit and suits. Print that suit out. What do I get from that? Well, I get all of my suits. Perfect. So I'm iterating over each one of them. And now what I'm going to do is I'm actually going to iterate over each one of these inside of my iteration of each of the suits. And you'll see what I mean by that. So now I'll say for rank, comma, points in rank and point the items. So if you remember when we did our dictionaries, our dot items method on our dictionary will return us both the key and the value. I'm actually going to get rid of this, and we're going to see how that shows up. We're going to print rank. We're going to print points. You see at A11, K10, Q10, stuff, so on and so forth. So are we okay with what I've sort of just talked to you guys about here with this loop over my suits and then how I'm iterating over all of the items in my dictionary? Are we all good with that? Yeah, awesome. So we have that, okay? And basically this whole rank points thing, I need to iterate over that for each suit, okay? So I'm going to tab in, I'm gonna put for suit in suits, right? Because for every suit you have to go through all of these again. So if I print out suit, rank, and points, so suit, rank, and points, you get like a bunch, right? Because you have to have your ace of hearts, but then you also need to have like your diamond of, or sorry, your ace of diamonds and all that stuff. That's why we were putting a loop inside of a loop. But this is great because now we have our suit, our rank, and our points, the exact things we need to create our card class. So we can say new card equal to a card, and our card takes a suit, rank, and point. So suit, rank, and point. I'll make this points, not point, not points. Okay, we've done that. And now what we're going to do with this new card is we're going to add it to our deck. So say deck dot append new card. When I run this, nothing will happen. I just won't get any errors. Perfect. So let's go through this and talk about what we've done. We've created a class called card. Every card, when initialized, will take a suit, a rank, and a point. Every card also has the ability to be formatted in a way where it looks kind of nice. It gets printed like it's a little text card, like you're holding on in your hand. Now I've created a deck. The purpose of this deck is basically to store all of my cards once I create all of them in this series of loops. I have all my suits saved to a list. I have all my ranks and points saved in a dictionary. So every rank has its associated dictionary, or sorry, every rank has its associated point value. Okay? So basically, I'm going to iterate over each of these suits, right? Because again, you have your ace of hearts, you have your ace of spades, ace of clubs, ace of diamonds. I have to go over each of these suits. And within each of these suits, I then go over each of these ranks and points and use them to create a card. That card is then going to go ahead and be saved to my deck. Okay? So once I've run this whole loop, I should be able to print out the length of my deck. And again, I get 52. So I have a deck of 52 cards in my deck. I have 52 cards in there. And that checks out. And it looks like we're all good with that. So now let's sort of work into the final thing that I wanted to go over is let's take our deck, right? So if I say for card in deck, print card, print card. What is this? This looks like gibberish, right? Main.card object at yabba 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 yabba. Well, basically, you technically are printing out the card. This is just like where it's stored in memory. But we want it to print out nice like this. So we're going to say, instead of saying print card, we're going to say card dot card. Okay. Now when we run this, yada, you have all of your cards printed very, very nicely. And they're all printed in the order which created them. Right? So you have your ace, kings, queens, right? Ace, kings, queens. So it's all in the order in which we created them. So what I'm going to go ahead and do now is we're going to tie in an element of something we touched upon 2 lessons ago, our random library. Import random. And if you remember from the random library, we have the ability to take a list and shuffle it around to randomize it. So it's not just, no deck of cards is just going to be straight up like this, where all your suits are stacked up nicely, ace, kings, queens, jack style. No, they're all shuffled up. So now what I'm going to come down here is I'm going to say random.shuffle our deck. Okay, so our deck has been shuffled. So now if we print this, now it's all out of order, right? You're getting spades, clubs, hearts. They're not all grouped up into a nice way. You're going jacks, 9, 7, 8, instead of ace, king, queen, jack. So we sort of shuffled our whole deck together. So, thoughts on this? How do we feel? Um, how do we feel about OOP in general? You guys like it? You guys not a fan? Any questions as well, like in terms of what you can do with this sort of thing? No questions? Okay. Maybe my chat is bugging as well. Still new, not quite sure what I could do with it. Let me think of. I'm trying to think of some examples where I use classes a lot. Um, Basically, I had uh, this weather application, right? And I basically modeled the entire application as a class. So it's literally like class application. And everything was just condensed under this whole class's sphere. And what that allowed me to do is, you know how like when you have like a window open, you get like a little title right here or something like that. I could directly manipulate things like that, and it just made things a lot easier. Yeah, it looks nice, but not don't know what to use it for. Yeah, this is like really basic examples where we're using it. If I go to GitHub real quickly, I can pull up. Again, this is gonna look kind of confusing, but again, I just wanted to emphasize how often I use classes. Classes are used for everything I do. Everything is a class when I'm coding. So yeah, you see it when you work into more complex examples. For things like this, um, it just doesn't really, display its usefulness, right? But all I'm saying is think about how you would sort of build this without using classes, right? How would it look? It wouldn't look as, as nice or as easy to understand, is what I'm saying. So if we came over to like our car class example, right? What would we do if, if we want to save like our attributes, right? That'd be pretty straightforward. We could use like a dictionary, right? You could say like car1 is equal to this, and we can say, the color is equal to, blue or whatever. Pretty straightforward. But then how do you add this ability to run functions off of it? You know what I mean? And take those values and manipulate them and work with them. So that's where you can see classes really do shine, and they work really, really great. So before we come to an end, and I actually finished a lot earlier than I thought I would. There's actually one more thing I wanted to talk about. Very true. Combines functions and storage stuff into one place. Yeah. And another thing about classes, and I'm actually going to save this for our next lesson, is let's say I have a vehicle class, right? A vehicle class. And I wanted to create a class for a boat and a car, right? Boats and cars are both vehicles, right? In terms of like, the hierarchy. So instead of repeating my code and putting, self.manufacturer is equal to manufacturer, I can actually inherit, yeah, from my vehicle class. And it saves me a lot of time, saves me a lot of code. And we'll see that later on. Because I don't think I want to cover that right now because I'm just eyeing the clock. And to be completely honest, I don't have anything else for us to go over because I thought it would take us a little bit longer than it did. Yeah, no worries. I'm trying to think of like a good project um, that we could just sort of like outline with you guys that might be worth learning or going over. I'm trying to think like a game because all the things that we built already, like rock paper scissors and all that stuff, um, it's been really there's really no need for it to be represented with classes. No questions today. You know what? I think I'm just gonna go ahead and because again, I really didn't think that we'd get this far. I call this. I think I spelled that wrong. I did. That's gonna bug me. Assignments. Okay. I apologize, guys. Everything else is always so nicely laid out, but not today. Okay. So I'm gonna create a class. We're gonna call it um, human. Pretty simple. I'm gonna create my dunder method. Again, this is a question. So you don't have to follow along with this. Just bear with me. Um, okay, so you have this class structure. Now, what I want you guys to do is basically tell me what I need to manipulate. All right, what do I change? Actually, let me come down here and I'll say R is equal to human. Say name. We already know this is going to throw an error, right? So what do I need to manipulate? Both within where I'm creating my instance of my class and where I've declared my class. So what are the things that I can change so that this won't throw an error when I run it? I'll give you guys a second to do that while I peruse my code to see if I can find a good game or something we can mess around with. Need self and name in the dunder. Perfect. You've got the colon there, but that wasn't intentional. And self.name is equal to name. Right, self.name is equal to name. So I'm assuming you want me to get rid of this pass as well. Okay. Anything else I need to go, or am I good to test this out? There's one more thing I'm looking for. Have to assign an actual name to R. Yeah, how do I do that? How do I assign an actual name to R? Now, there's actually two ways to do this. Actually, there's not two ways to do this. There's only one way to do this. What are we thinking, folks? How do I assign an actual name to R? I was thinking R is equal to human. Yep, perfect. Inside this, we'll put Luke. Yeah, when I run this, it won't throw up any errors. Good. I thought that was going to throw you guys off, but it didn't. Um, Jesus, you know what? We're not going to waste. I'm not going to waste any time just like sitting here and trying to come up with different questions. Um, I think we've come to the natural end of this lesson, even though it is 18 minutes short of what I would have liked. But regardless, good job. Here, let me take a look on Practice Python to see if they have anything. I don't think they do. They have a lot of like not OOP stuff on here. So yeah, that's today's lesson. Lesson 11. We talked about classes, creating classes, our dunder methods, right? That was pretty fun. Adding methods to our classes. And we took all of those and we used them in 3 different examples. So we had a human class example where right here we're declaring our human class. And we've created this method called introduce. So when I create into my class, I should be able to introduce them and it'll print out, hi, my name is their name and my hair color is hair color. I also created a class called car where I explored the idea of manipulating my attributes both inside and outside of the class declaration. And then we built a really, really simple game. Not really a game. This is actually, we're going to build up on this later. We can use this to make a game where it's all nice and pretty. But we've created a game, or sorry, the basics of the game where all your cards are classes and these things all have their own suit, rank, and point. And when you print them out, they print out all nice and tidy like that. So that is it for lesson 11. Will we review this next week before moving on to something new? Yeah, because we're not going to have a review lesson tomorrow. Next week when we come back, I will be sure to go over all of this because again, it's going to be a week by then. I will make sure we review it and we'll go by it quickly, and then we'll transition into learning more. If you figure out a good project to practice this, drop it in Discord. Yeah, I will be sure to put it somewhere where you guys can see it. I just can't think of any good projects. I'll have to look it up. But if you guys get bored over the week, and you want to practice, just look up like Python class projects, something like that. Work on it, bring it back to us next week, and we'll try it out, test it out for ourselves. In terms of that, I will see you guys next Saturday. Next Saturday is going to be the 13th of August. I'll see you guys at 12 p.m. Eastern Standard Time for lesson 12. All good news. It's a good excuse for me to work on my Common App essay instead. Oh my god. Why'd you have to remind me? Oh my. Okay. Any case, stay safe, keep practicing, be well, guys, and I will see you next time.